What is NASA searching for in the deep ocean? NASA, the agency that first took humans to the moon, the agency that sent sophisticated rovers to the red planet Mars and searched for life on its surface, is embarking on a different kind of secret mission today. This time, their destination is not some distant star in space, but the most remote and dangerous place on our own planet, the Mariana Trench. Hearing the name of this deepest trench on Earth brings to mind darkness, extreme pressure, and silence, where sunlight never reaches, where the water pressure is so intense that it can crush any ordinary submarine like a plastic toy in an instant. According to scientists, if a person were to descend to this depth, it would take less than a millisecond for his existence to cease. Every cell in the body would stop, and the bone marrow would be crushed under the intense pressure. And it is in this death trap that NASA scientists have made an unprecedented discovery, which could completely change the conventional ideas about our solar system. Not only that, scientists believe that if this deep-sea expedition is successful, we may be able to prove the existence of alien life within our solar system. But the question is, how? What is the relationship between alien life and the depths of the Earth's oceans? How can an underwater robot help us unravel the mysteries of another planet in our universe? In today's program, we will try to explain that complex journey in simple terms. This video is going to be very interesting. I am Sean, and I will be with you the whole time. So, start by giving this video a like. On the 14th of October 2024, at 12:06 p.m., a giant rocket lifted off from NASA's Kennedy Space Center. The rocket, built by Elon Musk's SpaceX company, was carrying a historic NASA mission, the Europa Clipper. Over the next 6 years, it will travel nearly 2 billion miles to reach Jupiter's orbit, and there it will search for new life. But Jupiter is mostly made of gas. How will we find life there? The answer lies in Jupiter's small moon, called Europa. Europa is particularly important among Jupiter's 95 moons because scientists believe that there is a vast liquid ocean beneath this icy moon. NASA has invested about $45,000 million in the mission because they believe that life or alien life may exist on Europa. But the question remains, the closest potentially habitable planet to Earth is Mars, where life has not been found despite numerous missions. So how could life survive on a planet as remote as Europa, which is located about 620 million kilometers away, extremely cold, with a temperature of -150 degrees Celsius, and which is devastated by radiation? To find the answer, NASA is now conducting research in the deep ocean of the Earth. Before any attempt to search for life on Europa, they need to understand how life can survive in the most hostile environment, and they are getting that lesson from the most remote environment on our planet, the Mariana Trench. Humans have set foot in space many times, but we all know how difficult it is to survive in space. There is no oxygen, no gravity, and there is intense radiation. You cannot survive even a moment without a spacesuit. But is there a place on our planet where survival is almost impossible? Yes, the ocean. The depths of the ocean are like another universe, where the extreme conditions of the environment are as cruel as space. That's why NASA has been working with the American Navy on various expeditions to the sea since its inception. The purpose of the Sealab 1 expedition in 1964 was to see how humans could survive underwater for long periods of time, how they could perform their daily tasks, and how the extreme pressure of water affects our bodies. The main goal of these expeditions was to verify a simple truth: if humans could survive underwater, they could survive in space. Even today, the world's only underwater research laboratory, the Aquarius Reef Base, located 19 meters below the surface off the coast of Florida, continues to conduct regular research. This mission is called NEEMO, NASA Extreme Environment Mission Operations. Every year, NASA sends scientists and astronauts here for several weeks where they practice spacewalks. This is because underwater, the effects of gravity are reduced and every movement while swimming resembles a spacewalk in space. Here, they must wear special suits, perform repair tasks, and live in a confined environment just like on the International Space Station. But today's mission is not taking place at that 19-meter depth. It is going much deeper into a far more challenging environment. And this time, instead of humans, a powerful robot is being sent. It is even more capable than a Mars rover, but also much more difficult to operate. Why? About 71% of our planet is covered by oceans. Yet, we know only about 20% of this vast body of water. To this day, we know more about the Moon and Mars than we do about our own oceans. Why? Because the deep ocean is an entirely different and largely unknown world. Take a look at this ocean depth graph. Nearly 90% of the marine life we commonly see, such as whales, sharks, crabs, turtles, fish, and various aquatic plants, lives within this upper region of the ocean. Sufficient sunlight reaches this zone, allowing life to flourish. In addition, this region extends only to about 200 meters in depth, so water pressure remains relatively low. However, the deeper you go into the ocean, the more intense the pressure becomes. For every 10 meters of depth, pressure increases by approximately 1 atmosphere. At just 10 meters below the surface, the pressure is already double what we experience at sea level. Once depths exceed 1,000 meters, the pressure becomes so extreme that most human-made underwater vehicles cannot survive. The 2023 Titan submersible implosion reminded us how quickly and brutally water pressure can crush a machine. The submersible imploded at a depth of about 3.5 kilometers, under nearly 400 atmospheres of pressure. It is believed that the passengers died so rapidly that they felt no pain. Pain signals take about 25 milliseconds to reach the brain, but the vessel collapsed in even less time than that. I hope you can understand that the deeper you descend into the ocean, the closer you come to death. Yet, NASA's current expedition begins at a depth roughly 3 times greater than that. One of the most dangerous regions of the ocean is the Hadal Zone, which begins around 6,000 meters, 6 kilometers, below the ocean surface. No sunlight reaches this realm, and the water pressure can exceed 1,000 atmospheres. The deepest point of this Hadal Zone is the Mariana Trench. Until today, only 3 people had managed to reach Challenger Deep, the deepest known point in the Mariana Trench, located nearly 11 kilometers beneath the ocean's surface. In 1960, when Don Walsh and Jacques Piccard first descended into the depths of the Mariana Trench aboard the submersible Tries, scientists' understanding of life changed forever. The Mariana Trench, a place that could be described as hellish, was found to harbor life. Scientists were astonished to discover that even at such extreme depths, a variety of creatures exist. For example, the Hadal snailfish is found at depths of around 8,000 meters, while a shrimp-like creature called the amphipod can survive even 11,000 meters below the surface. But the question is, how can these organisms survive under such immense pressure, where most creatures cannot? How do they live without sunlight? What do they eat? And what does all of this have to do with alien life on other worlds? Scientists have discovered that these animals possess special biochemical adaptations. One important molecule involved is called piezolite, which helps protect their cells from extreme pressure. For food, they rely on dead organic matter drifting down from the upper layers of the ocean and on chemical energy sources. Although sunlight never reaches these depths, there are hydrothermal vents, cracks in the seafloor, similar to underwater volcanoes, through which superheated water, minerals, and chemical compounds emerge from Earth's interior. The temperature around these vents can reach 300–400 degrees Celsius. The hot water released by hydrothermal vents contains chemicals such as hydrogen sulfide, methane, iron, nickel, and many other compounds. Tiny bacteria convert these chemicals into energy through a process known as chemosynthesis. These bacteria are the true producers of the deep-sea ecosystem. They create organic matter within their bodies, which then serves as food for smaller organisms. This discovery taught scientists another fundamental truth. Sunlight is not essential for life to survive. Chemical energy alone can sustain entire ecosystems. The fact that life can thrive under such extreme conditions has inspired NASA to search for extraterrestrial life around Jupiter. By now, you may understand the connection. Next, let's discuss how life in Earth's deep oceans relates to the possibility of alien life. In 1997, when NASA's Galileo spacecraft flew close to Jupiter's moon Europa, it collected astonishing data. The spacecraft observed that thousands of gallons of water were being ejected from Europa into space every minute, reaching hundreds of kilometers above the surface. This prompted scientists to conduct further research on Europa, and one surprising discovery after another began to emerge. Europa is smaller than Earth's moon, and its surface temperature is around -150 degrees Celsius. However, scientific studies suggest that beneath its icy shell lies a vast ocean containing roughly twice as much water as all of Earth's oceans combined. Yes, that's right. Europa is covered by an ice layer approximately 15–20 kilometers thick, beneath which lies a salty ocean that may be around 100 kilometers deep. Scientists did not arrive at these conclusions based on science fiction. They have several lines of evidence supporting them. In 2013, the Hubble Space Telescope captured images of Europa showing water plumes erupting through cracks in the ice. Scientists estimated that the amount of water expelled from Europa every 8 minutes would be enough to fill an Olympic-sized swimming pool. When these plumes shoot into space, they carry samples from the subsurface ocean, making it possible to study the ocean's composition directly. However, water alone is not enough for life. Life also requires energy and essential minerals. Scientists have confirmed that Europa's interior is still geologically active. In 2023, the James Webb Space Telescope detected significant amounts of carbon dioxide and hydrogen peroxide on Europa's surface. Furthermore, when NASA's Juno spacecraft flew past Europa, observations indicated the presence of oxygen on its surface. Due to radiation interacting with the icy surface, approximately 12 kilograms of oxygen are produced every minute on Europa. At that rate, the amount of oxygen generated each day would be sufficient to support about 1 million people. Scientists believe that if even a portion of this oxygen reaches the ocean beneath the ice, the chances of life existing there would increase significantly. At this point, you may wonder whether life beneath thick layers of ice is even possible. To answer that, consider an interesting discovery. In 1973, scientists identified a massive freshwater lake beneath Antarctica's ice sheet called Lake Vostok, located under nearly 4 kilometers of ice. For hundreds of thousands, perhaps even millions of years, no sunlight had reached this lake, nor had any modern organisms been able to enter it. Yet, when scientists analyzed water samples from the lake, they discovered previously unknown types of bacteria. Some appeared to be remarkably different from known bacterial species on Earth. Now think about it. Life exists 11 kilometers below the surface in the Mariana Trench, in the extreme cold of Antarctica, and even around active volcanoes. If life can survive in all of these extreme environments, is there any compelling reason to assume that life could not exist on Europa? This leads to another question. Why is NASA conducting research in Earth's deep oceans? At the heart of this entire story lies a practical challenge. How would we actually search for life on Europa? How could we penetrate 20 kilometers of solid ice to reach the ocean beneath? What kind of technology could melt through that ice? How could such equipment survive the intense pressure and freezing conditions? Most importantly, what kind of life should we be looking for? What might such organisms look like? What would they eat? How would they obtain energy? To answer these questions, NASA has turned its attention to Earth's deepest oceans. In 2014, NASA supported researchers used the deep-sea robot Nereus to explore the Mariana Trench. However, at a depth of nearly 10 kilometers, the vehicle imploded and was destroyed by the immense pressure. Learning from that experience, scientists developed more advanced systems such as ORPHEUS, a powerful autonomous underwater robot designed to gather data from the deep ocean. Researchers are studying how deep-sea bacteria survive, how chemical energy supports ecosystems, and how organisms adapt to extreme pressure. This knowledge could prove invaluable for future missions to Europa. An even more ambitious plan involves a special robot known as a cryobot. If the Europa exploration program progresses successfully, NASA may eventually send a cryobot to Europa's icy surface. Powered by nuclear energy, the robot would slowly melt its way through the ice and descend toward the subsurface ocean. Once there, it could collect samples and transmit scientific data back to Earth. The engineering lessons learned from exploring the Mariana Trench are expected to play a crucial role in developing such technology. What will Europa Clipper's long and complex journey look like? Launched in October 2024, Europa Clipper is an engineering marvel weighing nearly 6 tons. Traveling all the way to Jupiter requires an enormous amount of energy, and carrying enough fuel for a direct journey would be impractical. Therefore, scientists are using a technique known as gravity assist. The spacecraft will use the gravitational pull of planets to increase its speed. It will perform a carefully planned trajectory involving flybys that allow it to gain momentum while conserving fuel. After receiving a final gravitational boost from Earth, it will continue its journey toward Jupiter. The voyage will take approximately 6 years. Around 2030, Europa Clipper is expected to arrive in the Jupiter system and begin detailed investigations of Europa. Its mission will be to study the Moon's ice, shell, subsurface ocean, chemical composition, and habitability, helping scientists determine whether one of the most promising locations for extraterrestrial life in our solar system could actually harbor living organisms. Once it arrives, Europa Clipper will perform 49 flybys of Jupiter and pass extremely close to Europa during each encounter at altitudes as low as about 25 kilometers above the Moon's surface. Using its 9 sophisticated scientific instruments, it will measure the thickness of Europa's ice shell, estimate the depth of its subsurface ocean, create temperature maps, and, most importantly, fly directly through water plumes erupting from the surface to analyze their chemical composition. If any signs of microbial life are detected, it would rank among the greatest scientific discoveries in human history. It is important to remember that this mission will not land on Europa. Its purpose is solely to observe and transmit data back to Earth. After completing its mission, around 2034, the spacecraft is expected to be directed toward Ganymede, another moon of Jupiter. Interestingly, scientists believe that Ganymede also contains a vast ocean beneath its surface. However, the ice covering Ganymede is much thicker, approximately 160 kilometers deep. Because of this enormous challenge, NASA is not currently focusing on exploring Ganymede's ocean in the same way, as it remains beyond our present technological reach. NASA's deep-sea research is not simply about understanding the depths of Earth's oceans. It is part of a much larger effort to understand our place in the universe. Earth's deepest location, the Mariana Trench, and Jupiter's moon Europa are two very different worlds, yet they are connected by the same fundamental question. Is life unique to our planet, or is it widespread throughout the cosmos? That is why NASA continues to invest significant effort into studying Earth's oceans. Scientists want to understand how life emerged and survives in extreme environments, and how robots such as ORPHEUS can safely operate under immense pressure and in complete darkness. The knowledge gained from these studies could help future missions explore the ocean hidden beneath Europa's icy crust. For this reason, NASA launched its SUBSEA, Systematic Underwater Biogeochemical Science and Exploration Analog program in 2017, combining research on deep ocean ecosystems with the search for life beyond Earth. By studying both environments together, scientists can develop technologies and strategies that may one day be used to explore alien oceans. It is entirely possible that in the not-too-distant future, humanity may discover a completely new form of life. And if that happens, it could become the greatest discovery in human history, a confirmation that we are not alone in the universe and that life exists elsewhere beyond Earth. So, what do you think? Could an unknown form of life be hiding in Europa's dark ocean? Or is it simply a vast, lifeless body of water trapped beneath layers of ice? Let me know your thoughts in the comments below. And if you're interested in learning more about space and science, don't forget to check out my previous videos. That's all for today. I'm Sean, and it was a pleasure being with you. Stay well, stay healthy, and I'll see you again in another exciting adventure.